Hey guys, Mr. Backerberg here. In this video, we're going to look at the Pythagorean Theorem. When we're talking about the Pythagorean Theorem, we're going to be working with a right triangle. So we've got this right triangle and the sides are labeled A, B, and C. Now before we get into what the Pythagorean Theorem actually is, there's a little bit of vocab that I want to go over. The first thing is the hypotenuse. And the hypotenuse is one of the sides of the triangle, but it's always the side that is opposite of our right angle. So this angle down in the bottom left-hand corner of our triangle has that little box in the corner. That means that that's a right angle or a 90-degree angle. So the side across from it is the hypotenuse. So in this case, side C is the hypotenuse. Now the other two sides, those are called legs. So the legs are the sides that form the right angle. So side A and side B form the right angle, so they're the legs. Now what the Pythagorean theorem is it's really a relationship that relates the size of the legs to the size of the hypotenuse. And the way the Pythagorean theorem works is it says that if you take that A leg and square it, and then add the B leg squared, that should equal the length of the hypotenuse, C squared. And when we're doing the Pythagorean theorem, the hypotenuse always has to be the C value. So we're going to look at a few examples in here. So we're looking at this triangle where one of the legs is 7, the other leg is 10, and the hypotenuse, we don't know what that is, but that's what we're going to try to find. So we're going to use the Pythagorean theorem. So remember, the Pythagorean theorem says a squared plus b squared equals c squared. And the really important side is the hypotenuse. That always has to be the c value. So in this case, the hypotenuse is x. So on the right-hand side where that c value is, I'm going to fill in x. And I have to square that. Now, as far as the legs go, it really doesn't matter which one is A or B. We just have to make sure that we get them both filled in. So maybe the 7 is the A, so I'm going to go 7 squared there. And maybe the 10 is the B, so I'm going to go plus 10 squared there. Now, we're going to take care of simplifying this down and hopefully solve to figure out what our x value is. So if I do 7 squared, that's 49. And if I do 10 squared, that's 100. And that's going to equal x squared. Now on the left-hand side, we've got some addition happening. 49 plus 100 is 149, and that equals our x squared. But now we want to figure out what our x value is, and right now we have x squared. So in algebra, when we're solving something, we always want to use inverse operations. So the inverse, or the opposite of squaring something, is square rooting something. So in order to cancel out this squared on the x, I'm going to have to square root it. That's going to allow us to cancel out that squared power. But whatever I do to one side of the equation, I also have to do to the other side. So I also have to square root this 149. Now, one thing we talked about with square roots is that we always want to simplify them down as much as possible. But if we try to make a factor tree for 149, there's nothing that's going to divide nicely in there. 149 is actually prime, meaning it doesn't have any other factors besides 1 in itself. So there is no way for us to break down this radical at all. So this hypotenuse, we're just going to say that x is the square root of 149. Now, if I look at this other example, now I'm missing this leg. So one of the legs is 4. We don't know this other leg, but now we do know that the hypotenuse is 6. And again, like we talked about before, the hypotenuse is the really important value. That always has to be c. So in this case, that c value is 6. So I'm going to go 6 squared on the right-hand side. Now, as far as the legs go, again, it doesn't matter which one you choose to be A or which one you choose to be B. So I'm going to let the 4 be that A value. So I'm going to go 4 squared, and I'm going to use y as my B value this time. And again, I'm going to work on solving to see if I can figure out what this missing side is. So we've got 4 squared. 4 squared is 16. We don't know what y is, so we can't really square that. And on the right-hand side, 6 squared is 36. Now I want to get that y alone, and right now I've got that 16 on the left-hand side. So to get rid of that 16, we're going to have to subtract 16 on both sides. So that's going to give me y squared equals 20. But again, I don't want y squared, I just want y. So in order to get rid of that squared on the y, we're going to have to square root both sides of our equation. So we're going to get y equals, now when we're square rooting this 20, we want to try to simplify this down. So I'm going to think about making a factor tree in here. The factors for 20 are 4 and 5, but 4 breaks down into 2 and 2. I see that we have a pair of 2's, so I take 2 out of the radical. This 5 didn't get paired up with anything, so it stays underneath the radical. So that missing y leg is 2 times the square root of 5. A couple more examples here, but now we don't have pictures to take a look at. But here's what I know. I know that this a value is 20. I know that the b value is 15, so I'm missing the c value. So again, we're going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared, and we're going to try to figure out what that missing c value is. So I know that my a is 20, so I'm going to go 20 squared, plus I know that my b is 15, so I'm going to go 15 squared, but I don't know what my c value is, so I'm going to put c squared there. Now on the left-hand side, if we square 20, that's going to be 400. And if I square 15, that's going to be 225. And on the right-hand side, we still have c squared. Now, if I add up the left-hand side, 400 plus 225 is going to give me 625, and that equals c squared. Again, I want to get c alone, and I've got that squared power on it, so I'm going to square root both sides to cancel out that squared. And on the left-hand side, we're square rooting that 625, and 625 is actually a nice perfect square. When you square root 625, the answer that you get is just 25, so that missing c value is just 25. Now in this example, we've got a b value of 6 and a c value of 9, so we're missing the a value. So again, we're going to use the Pythagorean Theorem, a squared plus b squared equals c squared. I don't know what a is, so I'm going to leave that as a squared. I know that my b value is 6, so I'm going to go 6 squared. And I know that my c value is 9, so I'm going to go 9 squared there. Now, there's not much that we can do with a squared, so I'm just going to leave it as a squared. 6 squared is 36, and 9 squared is 81. I want to work on getting a alone, so right now I see that plus 36. So I'm going to have to subtract 36 on both sides. And if we do 81 minus 36, that's going to be 45. So we get a squared equals 45. But I don't want a squared, I want just a. So I have to square root both sides in order to cancel out that squared power. Now as far as 45 goes, I'm going to make a factor tree here. It's not a nice perfect square, but I think we can break it down. 45 is 9 times 5, and 9 is 3 times 3. So I see that we've got a pair of 3's. So I'm going to take the 3 out of the radical. This 5 didn't get paired up, so it stays underneath the radical. So that missing a side is 3 times the square root of 5. Now we're going to wrap things up with a couple of word problems. So the first one says that we've got a 10-foot ladder leaning up against the house, and the base of the ladder is 4 feet away from the base of the house. We want to figure out how far up on the house the ladder touches. Now, anytime we're dealing with a word problem, I think it's helpful to draw a picture representing the situation. So I'm going to draw in a vertical side to represent the side of my house. My ladder is leaning up against it at an angle, and then the base of the ladder is 4 feet away from the base of the house. Now I'm going to label some sides on here. The ladder itself is 10 feet long, so the ladder was leaning up against the house. So this diagonal side is the 10-foot ladder. We said that the base was 4 feet away from the house. So on the ground, that distance from the base of the ladder to the base of the house, that's 4 feet. And we don't know this missing side. So I'm going to call that x. Now this is a right triangle, so we are able to use the Pythagorean Theorem. So remember, that's a squared plus b squared equals c squared. And the important side is the hypotenuse, so across from the right angle. That always has to be your c value. So in this picture, that 10-foot length is the c value. So I'm going to put that on the right-hand side. Now, as far as the left-hand side goes, it doesn't really matter which side is a and which side is b. So I'm going to use x for a. So I'm going to go x squared plus, I'm going to use the 4 for the b value, so 4 squared. Now, if we look at what's going on in here, 4 squared is 16. So we've got x squared plus 16, and on the right-hand side, 10 squared is 100. Now I want to work on getting x alone. Right now I see this plus 16, so I'm going to subtract 16 on both sides. So we're going to get x squared equals 84. And I want to get x alone. Right now we've got that squared power on it. So I'm going to square root both sides. So on the left-hand side, the squared and the square root cancel out. So we just get x equals. Now as far as the square root of 84 goes, I think we're going to be able to break it down. 84 is 12 times 7. 12 is 4 times 3. And 4 is 2 times 2. So we've got a pair of 2's. So we can take the 2 out of the radical. 3 and 7 don't get paired up, so I want to put those together underneath the radical. So that's going to be the square root of 21. But when we're solving an application problem, this square root answer doesn't really make a whole lot of sense. Nobody really knows how long 2 square root of 21 is. But if we can approximate that to be an actual length, that might be more useful. So if I just do the square root of 84 in my calculator, I'm going to get about 9.17. But I always want to label my answer, so I'm going to put the feet label on there since that's how we were measuring. So I know that this answer is just a little bit more than 9 feet. So when you're dealing with an application problem, it might make more sense to get a decimal answer versus having a square root answer. Now the last example we're looking at, you're walking to your friend's house, but you can't cut through the neighbor's yard because there's some fences blocking the way. So you're going to have to walk due east 6 blocks and then due north 10 blocks. But we want to figure out what would that straight line distance be if you could cut through the backyards. Now we're going to draw out a picture to help us represent this situation. So I'm going to let this dot right here be your house. Now you have to walk due east 6 blocks. Due east means directly to the right, 6 blocks, so that's a distance of 6. Then from there you have to turn and go north 10 blocks. So north is going to be up, and that distance is 10 blocks. So this is your friend's house right here. And we're trying to figure out if you could go directly from your house to your friend's house, what would that distance be? So we do have a right triangle in here, and we're trying to find, in this case, that hypotenuse. So we're going to use the Pythagorean Theorem. So a squared plus b squared equals c squared. We're missing the hypotenuse. We don't know that length, so I'm going to fill that in for c on the right-hand side. For the legs, it doesn't matter which one is a and b. So I'm going to use 6 as the a value, so 6 squared plus, and I'm going to use 10 as the b value, so plus 10 squared. Now we're going to solve to figure out what this x value is. 6 squared is 36, 10 squared is 100, and that equals our x squared. Now if we add up the left-hand side, 36 plus 100 is 136, and that equals our x squared. But we don't want x squared, we want just x. So to get rid of this squared, we're going to square root both sides. Now on the right-hand side, the squared and the square root cancel each other out, so we just get x. On the left-hand side, this is an application problem, so I'm going to type this into my calculator to get a decimal approximation. If you square root 136, that's going to end up being about 11.66. And I want to label this. We were measuring how many blocks this was, so it's 11.66 blocks. So if you could walk directly from your house to your friend's house, cutting through backyards and whatever else, it would be just a little bit more than 11.5 blocks. That's going to be it for this video. Thanks for watching.